Hey everyone, it's Canfield. So today we're going to be looking at the product rule and hopefully the quotient rule as well. So this is a pickup. We're still in chapter 8. Yeah, we're in chapter 8, techniques of differentiation. I'm on page 34 and I'm going to do the first example here. So this is 6a. So 6a says y is equal to 2x squared minus 4x times 3x minus 5. So I'm not multitasking. I'm not checking my email right now. I'm totally focused. Oops. Okay, so anyway, sorry. Okay, so right now the only way we know how to do this is to FOIL this out. And so y is still equal to, let's see, 2x squared times 3x, that's a 6x to the third. Then, let's do that. Then minus 10x squared, then minus a 12x squared, then plus 20. And so y then is equal to 6x cubed minus 22x squared plus 20. Cool. So now that we have y like FOILed out and simplified, now I can take the derivative of it and get y prime is equal to 18x squared minus, sorry, remember we take the 3 times the 6 and we get 18, we subtract it by 1. So here we take the 2 times the 22 and get 44 negative. Subtract the exponent by 1, and here it's just a plain constant, so it's gone. Okay. I wonder if there's a better way. I wonder if we could, can we just take the derivative of them separately and then multiply it out? Well, let's see what happens if we do that. I'm going to try this. And I am going to spoil it a little bit. This doesn't work. What if we tried, so the derivative of this one is 4x, the derivative of that one is minus 4, then the derivative of this one is just a 3. So when we distribute here, we get y prime is equal to 12x minus 12. And so yeah, we find that it doesn't give us the exact same thing, but this is actually pretty close to what we are going to do. It's kind of like if you take FOIL and taking the derivative and kind of mush them together. We have a special rule that says if we have two quantities multiplied together, we can't take their derivatives separately and just leave it the way that it is, but we can take the derivative of one of them, leave the other one alone, and then add that to the reverse. So, hold on, it's getting noisy outside. All right, so I'm going to kind of walk through how this works and then talk about a couple of memorization strategies for you, and then I'll share how I personally memorized it and still know it. So what I'm going to do is I'm going to take the derivative of this first piece, which is going to be 2x squared, that's 4x, and then here, right, y prime is equal to 4x minus 4, and that's going to be multiplied by this 3x minus 5. This is one part of what we call the product rule. Then I'm going to plus sign, and then I'm going to leave this one completely alone, 2x squared minus 4x, and take the derivative of this, which is just 3. So at the outset, in this problem, it's not crazy better, like, because if you want to, actually, hold on, we should see if this even works. So that would be 4x, 3x, that's 12x squared. Then 4x minus 5, so it's minus 20x, then minus 12x, then plus 20. Here I can distribute the 3 and get plus 6x squared minus 12x. So when we simplify this, I got 12x squared. Okay, so 12 and 6 of the x squared gives us 18x squareds. Then minus 20x minus 12x minus 12 more x. 20 minus 24, that's minus 44. I've got a plus 20. So I did something wrong. Oh, good. Go me. That's probably something really, really simple too. maybe I made the mistake earlier. Oh, at the very beginning. Oh my goodness. Sorry if you saw this earlier. So earlier, when I FOILed this all out, that should have been a plus 20x here at the end. When we take the derivative of that, we get plus 20. So now we should see the overlap between the two. So this and this are the same, and in the way that I did this only took a single step less, and it kind of is more work. However, if we had just written it like this at the very beginning, we could have left it like that. We didn't have to FOIL it all out like this. This was just to me showing that it works the same way. So in general, if we talk about this as y is equal to f of x, g of x, the product rule is f prime g plus g prime f. And some people will say y is equal to u v, and then they'll say y prime is equal to u prime v plus v prime u, which is fine. Other people like to say f prime g plus f g prime, or u prime v plus u v prime. But the idea is that we're taking the derivative of the first one, leaving the second one alone, and then taking the derivative of the second one, leaving the first one alone. And this is extendable to any number of terms. So like if we had f, g, and h here, all you'd have to do, like if we had f, g, h, it would be, that's supposed to be an arrow. It would be f prime, leave the g and the h alone, plus f, g, and h, but we take the g prime and leave the f and the h alone, and then we would take the derivative of the h and leave the other two alone, with pluses in the middle of all of them. Okay, so for our second example here, this one is actually a lot better than if we were to have to FOIL it all out. So if f of x is equal to x squared minus x minus 1, and this one is x squared plus 2. Well, so instead of FOILing it out, we're just going to take the derivative of the first one, leave the second one alone. That's a 2. All right, so f prime is going to equal something, then that's alone. Then we're going to leave the first one alone and take the derivative of the second one. So the derivative of the first one, let's see, x squared is 2x. Then minus x is that's going to turn into a 1. And the 1 is a 0, and we're good. Then here, x squared plus 2, well, it's just a 2x. And I'm just going to leave it there. I don't need to do any more work. This will FOIL out to a simplified version of the derivative. And it's the same thing that I would get if I FOIL it out first and then took the derivative. So this is an acceptable answer. And this is all I'm expecting you to do. I'm not expecting you to FOIL it all out. So for letter C, especially, unless it's a multiple choice question and they have it all FOILed out and simplified and we have to figure out which one it is, you're really only hurting yourself if you spend the time to do it. With problems like this, they're really trying to see if you understand, instead of FOILing this all out first, do you understand that you can simply take the first derivative, which in this case is 6x minus 2. Remember, 3 times 2 is 6. That's a plain x, so it goes away. Leave the second one alone. So took the derivative, left it alone, plus, I'm going to leave the first one alone. And then I'm going to take the second derivative of this. The derivative of the second one, sorry. Negative 5 times 4 is negative 20. So then it's going to be x to the 3. 2 times 3 is 6, so plus 6x squared minus 7 times 2 is 14, minus 14x plus 1. Boom. And that would be f prime. it doesn't make sense to multiply these out. It's tedious. It's a ton of work for no real benefit. On the AP exam, if they have something like this, a lot of times they leave it like this. Other times there might be a factoring trick or something where we can pull something out. We'll see more of those as we go this year, though. All right, so quotient rule. I want to kind of develop the quotient rule naturally. So the quotient rule, like, it is the product rule secretly. We don't have enough tools to develop the quotient rule naturally. The quotient rule is a lot uglier. So let's see, 7, just start a new page. But the trees. I know, your name is the Lorax, you speak for the trees. All right, so 7a says y is equal to 5 over 3x minus 2. Okay, so here's the quotient rule. Quotient rule is very, very similar. If you remember that in our product rule, it was f of x times g of x. The quotient rule says, hey, if you want to take the derivative, remember that just says take the derivative of f of x over g of x. I'm going to leave out the x's when I write it over here, just to help us understand the idea. Very similar to before, where we would do f prime g and then f g prime, like where the prime switches. The difference is quotient. Divide is subtract. And I wish it was just that. That'd be so great. Instead, it also winds up being divided by g squared. Not g prime squared, just g squared. So let's think about this. What's the prime of f in this one? Well, the prime of a number, the derivative of a number is just 0. And then on this one, the derivative of 3x minus 2 is going to be 3. Oh, so the derivative of each of them is just a number. So to do the quotient rule, this would be our f, this would be our g. So all you got to do, well, it says f prime goes first. Oh yeah, I should put little primes there. So f prime, that's 0 times g, which is 3x minus 2, minus f, the top, which is 5, times g prime, which is 3, all over g squared. 3x minus 2 squared. So this one I'm going to clean up just a little bit, just so we can look at it a little bit better. Because 0 times blah is 0, and then that's minus 15. So I'm going to say minus 15 over 3x minus 2 squared. You don't have to clean it up any more than that first step. But there are times that I can't not clean it up. Let's look at 7b. So it's got f of x is equal to 4x minus 3, 2x plus 1. All right, so let's do a different way to kind of approach this problem. Let's say first thing we'll do is we'll write the 2x plus 1 squared on the bottom. We know that's going to happen. And then we know there's a minus in the middle. And we know that the derivative of the top goes first and the bottom stays alone. And then the top stays normal and we take the derivative of the bottom. This could be another way that you try to set it up. You kind of remind yourself about which ones you do. So derivative of the top is just 4, derivative of the bottom is just 2, and we're done. And yeah, you could simplify this and get 8x plus 4, if you distribute the 4 here, minus 8x, oh, be careful with your signs here. So it's going to be minus 6 with another negative, so it'll be plus 6. Oh, that's actually kind of neat, because then we wind up getting just a 10 on top and then a 2x plus 1 squared. So, yep, that's our f prime. 7c. We have a negative x on top. X squared plus 4x minus 2. So if I'm trying to take the derivative of this, now I'm just going to, instead of trying to do different strategies, I'm just going to talk as I do it the way I normally do. So f prime of x is equal to, derivative of the top is -1, leave the bottom alone, minus, leave the top alone, derivative of the bottom. Okay, I lied, 2x plus 4. I think normally when I do this, I'll take the derivative of the bottom and write that, and then I'll write the top. But all over the bottom squared. It's annoying, but it's pretty similar. And if you recognize the similarity between this and product rule, you're going to save yourself a lot of headaches. Personally, the way that I think about it is I try not to use shortcut phrases, because my students use shortcut phrases and then they mix up the phrases and then they get the rule wrong. Instead, the concept that I'm thinking about is I'm taking the derivative of one piece at a time and leaving everything else alone. And I know that product is plus, and I know that quotient and product are inverse operations of each other. That means that quotient is minus. So that's how I remember what goes in the middle. And then I always do first prime first. And first is the top. So there's a lot of parallels that you can draw. I'm doing first prime first, and then leaving it alone, and then I'm doing the second prime second, and I'm leaving the other thing alone. Like, we're doing like one thing at a time. And I would just leave that answer. There's no reason to clean it up, even though we can and look nice, a little bit nicer. But the way that we were getting our answers before is nice. That's totally fine. Okay. The quotient rule scares student for some reason. So it's only allowed to scare one of you. And many will try and avoid it. There are ways you can kind of cheat it out and not do the quotient rule. Oh gosh. These are two really good examples. Let me write these down. Let me write them down correctly. So these are two derivatives that we could have done last class. We don't need a special rule to do these. Quotient rule will work, but there's no need. So in this first example, we can rewrite this as y is equal to x to the -2. And I can just use power rule here. I can say y prime is equal to -2 x to the -3. And just remember that negative exponent flips it down here. And you might go, Canfield, there's no way that that's and that are going to be the same. So just check it out. Well, let's see, derivative of the top in this one is 0, right? So that's going to be 0 times x squared minus the derivative of the bottom is 2x. So this is the way I actually do it. I'll put the derivative first. And then the top's just 1 all over x squared squared. And you're like, that and that, nuh-uh. And I'm like, because 0 times that is gone. And then up here we got -2x, and on the bottom we got x to the 4th. And you're like, nuh-uh. And I'm like, hey, we got an x and x to the 4th, so we can cancel the x, and we get -2 over x cubed. It's the exact same thing. But here we had to do quotient rule, and here we just were like, done. This one, quotient rule totally works. I'm going to say, instead of doing quotient rule, remember that fact that we've talked about before, that 3 plus 4 over 7 is equal to 3/7 plus 4/7. You can take a fraction and split it up as long as it's plus on the top. Plus on the bottom means we're ruined. We have to do quotient rule. But here, I could just rewrite this as x squared over x squared minus 3x over x squared plus 1 over x squared. And then, okay, well, that's 1. This is still just y. I'm not doing y prime yet. This is -3. I got x to the 1, x to the 2 on the bottom. That's 3. Just in case you're not sure what's happening here, that's -3x over xx. So we can cancel an x. and that's negative 3 over x, and that's an x to the 1, so I can flip that up to the top as a negative. And then here, just like in the previous problem, now I've got a tremendously easy problem. The derivative of that is 0. Derivative of that is positive 3x to the negative 2, and then minus 2x to the negative 3. I can finally rewrite this as 3 over x squared minus 2 over x cubed. And again, you might say, Canfield, there's no way that this is going to wind up being the same as that. And I'm like, haven't you picked up the pattern yet? So let's try this the awful way. Y prime, we'll take the derivative of the top. So that's what? 2x minus 3. That's a 3, I promise, times x squared. Minus, I really don't want to do all this. This is great. Thanks for not believing me. Derivative of the bottom is 2x. No, I'm just messing around. I appreciate your complaints. I think the more correct thing to be thinking now is, why is he talking to me like I'm responding? Because he's in a room by himself filming this. Okay, so if we FOIL this all out, I'm curious to see, does this, and like, do they get the same thing? Because if they don't get the same thing, there's an error somewhere. Like earlier in the video, I don't know if you remember, but I dropped an x somewhere. So here when I distribute, I'll get 2x cubed minus 3x squared. Then here, we're going to be careful because there's the minus. Let me put the parentheses first. So that's going to be 2x cubed minus 6x squared plus 2x. And then I'm going to have to distribute the negative to that one. And I'll bring in the x to the 4th underneath in a second. So that's 2x cubed minus 3x squared minus 2x cubed plus 6x squared minus 2x all over x to the 4th. So with a little bit of cleaning up, those are going to go away. Now you know when I'm filming this. Sorry about that. So the 2x cubed cancels out, then minus 3x squared plus 6x squared gives us plus a positive 3x squared. Then there's a minus 2x left over, all over x to the 4th. Remember, I can't just cancel willy-nilly, but I can split this up and say 3x squared over x to the 4th minus 2x over x to the 4th. You might be surprised to see that I get 3 over x squared minus 2 over x cubed. It's like it's a ghost. It's like it's the same thing. So, okay, so this doesn't completely finish the section, but this does get us through product and quotient rule, 2 of the biggest rules that we use in this class. So I hope it was helpful. This should get you up through question 27 in the homework. So I know in class, at the time of this filming this, my class isn't there yet, but I want to have these out before class just for anybody who needs it. So hope this was helpful. Feel free to shoot me a message if you have any questions. And yeah, that's it.